I think we are going to jump into some networking here. I think I want to do some prototyping, some ideating. Let's see. Let's see what we can come up with. So I've got some stuff sort of sprinkled around here. I pulled out. This is the old networking code. This is the driver for the adapter, and I just have this here because I want to be able to reference it, because I hope I can find everything I need in the documentation, but I don't expect that that's actually going to be the case. So let's also pull up that documentation. Data sheet and share this window. So I'm going to be trying to come up with a driver for the RTL8139, which is a network card that was released apparently about 2004-ish. Like I say, I already have one that works, but I really do not like this. A lot of these are the old kernel interfaces. Stuff like what doesn't exist anymore? Well, all of this stuff in the packet dispatch doesn't exist anymore, right? The like queue objects, Q and Q, none of this exists anymore. I also think that, I mean, it's kind of just a mess. And really the init function, it's probably fine to be a mess, just because it only runs once and I don't need to think that much about it. I'd really like to edit these to have real like offsets though, oh well, what is, I mean, I'm guessing OX30 above IO base is related to the physical buffer location, but it'd be great if this said, IO base plus physical buffer offset or something like that. So I think we have all of that information in the data sheet. Yeah, in the registered description. So like, let's just sort of check ourselves here. 0x30 as a physical buffer, 0x30 receive buffer start address. That seems sort of logical. I only named it phi buff. It'd be great if I named it RX buffer or something like that. And yeah, I did. Okay, so the physical buffer is mapped to the RX buffer range. So this is the receive buffer, and so that is what this means, and this is the correct thing to be looking at. So that's just a good little check. And we'll just probably give those some symbolic names in the new version of this. But a lot of, like, I really want this send packet to be clearer, especially stuff like this. Oh, tx slot mod equals 4 and plus equals 1. I think that's kind of nonsense, especially because we're waiting for the device to take the packet before we return. Like, there's no effort, no attempt at all to be parallel. The whole point of having multiple transmit slots is that you can send 4 packets at the same time, and not literally at the same time, but you can sort of queue up 4 packets to be sent, and the hardware will handle that in the background, where I'm just like, nah, loop while true until it's done. Yeah, to do, this could be async, and just make sure the script is done when we loop back around. I don't know how easy that's going to be. I don't imagine we're going to get here today, and I think we're going to start today, honestly, by doing a little bit of meta thinking. because I have tried to incorporate networking into this kernel now twice, and both times I won't say that I have failed, because I haven't failed. I got it working, and I disliked it so much that I ripped it back out. So, I mean, we can see some of that history if I grep the history, right? If I search the Git history for like net, there's a whole, I guess none of these have timestamps on them, but there's a whole bunch of different, this stuff happened in the, let me get a, how do I get a timestamp? Don't appreciate that I don't have timestamps. Oh gosh, git log. There we go. The formats, tree hash, parent hash, author names. I don't care about author name. I care about when. Author date. Committer name. Look at author date. %AI. Cat.git. Let's get what my alias actually is. There it is. Oh, because it's literally just that. Pretty. Okay, well that works, but I thought I was going to have more than that. And I don't really super want to have to figure this all the way out. So I think we might just give up. Because I guess it's on my work computer. I have a nice one-line git log that has timestamps. And that's really, it's good to use, but apparently I've never actually moved it over, and I don't want to reconstruct it right now. Trust me when I say, I guess I can, if we put this in less, net. So I was doing Unix sockets recently, remove all of the old bad stuff, refactor. Yeah. So I do have this file called networking prototype where I was writing some ideas down. And I mean, part of the challenge, I think, is going to be that, as I've said several times before, I'm really unhappy with the state of my file system right now. And sockets, this being Unix, they're sort of inexorably tied to files. So we'll probably have to figure something out as far as, like, do I use the existing file structures? Is there some way that I can completely bypass them? Maybe I can. I'm always a big fan when programming of the idea that you don't, like, I don't want to redesign the system that I don't like by ripping it out first and trying to rebuild everything from the ground up. Because this, I mean, files touch so many things. It's a Unix-like system. Processes can be accessed as files. I mean, sockets are files. There are procedural files that just do specific things. I have kernel modules that create files. I have kernel modules that write to files. Like, it's a huge ask to say, like, all right, let's sit down and redesign file. So what I like to do is, all right, let me design a new one that's completely divorced from the old one, and let's use that for one thing. And if it works well, gradually replace everything else with it. So maybe that's an interesting idea for the networking stuff, that we could like just start over. No file. Or no struct file. And net.c that is completely self-contained or something like that. Like what? You need an interface, you need a socket, presumably. Do you want to do, would we want to do I mean, part of what I don't like about the old system is that doing inheritance style programming is kind of annoying in C, and the file system is both inheritance and object orientation, and I mean that quite directly, right? The file ops is basically a vtable. These could be virtual functions if we were writing C++. They would be methods if we were writing Java. It's just a list of function pointers that are attached to every file and are different in the different kinds of files. So, right, this is just, well, socket file is essentially a subclass of file. It contains all the same fields as file, but it has additional information and different implementations of the methods above, as well as its own subclass methods. So I'm just basically building C++, and I don't want to do that. I don't like it. Hello, Chandu16. How are you doing tonight? Or today, wherever you are. So, how do we get away from that? I am doing well. If I had some magical inspiration, that would be even better. But I'm feeling pretty good. I was kind of tired earlier, but now I'm feeling pretty good. And let's see if we can't make some wonderful progress on this. The like third time around. So what did I ended up with? I work for a company. The reason that I'm interested in doing networking in my kernel is that when I went to college, I got a degree very closely related to networking. So I feel like really close to it. And then when I got out of college, I did support for networks. I was a network support engineer, is what they called me. Now I work sort of adjacent to that. I do web development adjacent to networking. It's like a front-end application that is used to control networking equipment. So this is not the stuff that I do at work, but it's like adjacent to that. And yeah, so low level is like what I do at home. And then at work, it's very, I'm not doing like the JavaScript, but I work on like the infrastructure and the automation to help the people who write JavaScript be able to do their jobs. I mean, the back end is a Rails app, and the front end is a lot of old like legacy pages that were just jQuery, and the new stuff is being migrated over to React, I think. I don't know. I don't do the front end, so. Yeah. Yes, exactly. DevOps, Cloud, CI/CD. Yeah. Cool. Yeah, those are all really great technologies. Docker and Kubernetes are going to be the big thing. So it's great that you're working on learning that. Those are going to be really big for cloud. Yeah, Rust is super cool too. There's a lot of really interesting work going on in Rust. I have a branch. I'm not actively working on it, but I have a, I guess it's not checked out here. I think it's called Rust. Why is it not? What is it called? I have a branch where I was working on incorporating some Rust into this project. If I can type the name of the project would help. Really? Oh my goodness, I really can't type it. Oh, it's called Integrated Rust, that's why. So, I don't know how interesting that's going to be. There's a folder called Rust. I think it's called Rust. What's it called? Kernel RS. Because, of course, I have to confuse myself. So, yeah. And I was working on like, oh, well, this is the print function for Rust. Static type checking, yeah, that's really helpful to have. I mean, I try as much as I can to do everything that I do. No, that's not true. I can't claim that everything I do is in a static language because I write a lot of Ruby. But everything that I do that's not Ruby, I like to have static type checking. And I pine for a way. I enjoy C for low-level stuff. I really, I prefer it to things like C++, just because it's so much simpler, it's so much easier to reason about. The specification is so much shorter. But this is, if there was one thing that I would get, that I would like, it's some way to do some type checking on these data structures. So this DMGR is just my name for a data structure that contains a pointer to anything. And in C, anything will become a pointer to nothing, and a pointer to nothing will become a pointer to anything just by implicit cast. So, you see this DMGR get returns a pointer to void, and void in C means nothing, right? But if I search for DMGR get, well, I'm pulling a thread out of a DMGR get, and I'm pulling an open file out, and I'm pulling more threads. And yes, it's definitely super not possible in Rust, and also happens to be the only way to do it in C, unless you make a bespoke data structure for every single one. The thing that frustrates me, if you talk to somebody, if there was somebody in the chat who enjoyed C++, they would say, oh, you should just make a data structure in a template, and then the template solves this problem because you've got type check in and out. But I strongly dislike the idea that, well, now I've got 5 data structures that are exactly the same, but separate copies of all of the functions and separate copies of all of the code being compiled, because literally what C++ is doing when you instantiate a template is copy pasting the code for every method with whatever slight differences the different types mean, and recompiling it, right? It's a separate pass, it's a separate compilation, so it slows you down every time you instantiate a new kind of template in every translation unit. And it balloons your binary size, because now I've got 6 copies of the same method, where all I needed was this like actually for DMGRs isn't even a good example of this because you don't even need to multiply. This I could parameterize it on types, but it would be literally the exact same code if I did. And I want somebody to come up with a language that you can parameterize on types, but all it does is tag in the type system. It doesn't actually change the code. And I've never been able to find, well, that's not true. It has been done. The only language that I know of and the only runtime that I know of that's ever done that is Java. The Java runtime works that way. And the Java compiler works that way. That if you say this is a generic method that takes a T, it actually takes object, and then the compiler is doing some checking for you and some casting for you. But that's obviously not very helpful when I'm trying to write an operating system. Rust does have pointers. They'll just tell you not to use them. Because they're inherently unsafe. But if you have like a function, apparently I don't have syntax on here, where a reference, right, is, ampersand t, and a mutable reference is mutable t. A pointer is star const t, and you can only dereference that in an unsafe block. So fundamentally, they sort of work the same as references, but a reference is safety checked and a pointer is not. That's basically the main difference. A reference is a kind of pointer. And C, you just have no choices. Everything is not safety checked, which is good, Keeps me on my toes. Let's see if this even builds right now. I think it should. Looks like it's going to. But you don't need safety checks. Oh, well, I was about to say you don't need safety checks. Look, this thing works, but then it didn't work. It broke right then. So that's kind of hilarious. Let's see if it breaks again. Nah, see, yeah. 60% of the time it works every time. You don't need no safety checks. Everything is perfect. Look, I can rotate 13. It's kind of funny that ABC becomes NOP. Look, I can edit the line. That was non-trivial. I don't know whether you believe it, but the ability to go back and forth like that took a lot of programming. And that's why I do it, because I don't know, it was hard and it's interesting, and it's an operating system. That's it's a whole. So when I do run here, this is starting up an x86 emulator, and booting basically a virtual machine on which I start initializing hardware and find a memory map and discover where RAM is and initialize a threading system, right? So this is a multi-threaded operating system. And yes, it does start a shell, but it starts a shell just as a way for me to, okay, I really need to fix that bug. It starts a shell, but it just starts a shell as a way for me to interface with an operating system. These are all programs that I wrote that run in the operating system. I use QEMU as the emulator that I use. And then, I can run programs and test stuff, and I can see system calls and pipe things. I'm a particular fan of pipes. That was a lot of fun to get pipes working. So I like doing the pipe to ROT13 because I think that's a lot of fun. And have I been through the source code for Docker and Kubernetes? I have not in any detail. I think I've looked at the source code for Docker once or twice, but I've never spent any time investigating the source code for Docker or Kubernetes. Why? This is Vim right now. All right. So what we're actually going to do is go into tmux so that I can split the screen. Nerd trait, I have used it in the past. I do not use it right now. No. So I just want to sort of note down, because I want to make some symbolic names for some of these registers, and so I don't want to make all of them because there's way too many. So I'm going to start out by sort of writing down which registers to name. I do use the fish shell on this machine at the moment, yeah. Well, almost all machines at the moment. I would use it at work, but they won't let me. So, IO plus 52 hacks, IO plus 37 hacks. 37 hacks, IO plus 30 hacks, plus 3C hacks, plus 40 hacks, IO plus 44 hacks, we just saw 37. Oh my fish? I think I don't use those themes now. I think this is just the default theme right now that you get if you just install it. I'm not a big customizer. You will notice that my Vim is also nearly completely stock. I'm doing very little in the way of customizing things. Just sort of how my brain works. Plus 20 hacks plus TX slot, 10 hacks plus TX slot, IO base plus control reg off, that's the 10x plus TX slot, TX adder off, that's the 20 hex plus slot, that's all in there. And what are we doing down here? 3E hex, 37 we already have before. 38. So 38 and 3 plus 38 hex, 3e hex. Okay. Now let's name them. Well, let's order them first, I think. Actually, I guess I can just... There we go. So, yeah, 10 hex, transmit status of descriptor. Zero. Ah, yes. Okay. What do you want? TS desk status 10. Define, and then OX20 our transmit start address, transmit status. I guess I shouldn't call that TS. TS desk status. It's a transmit descriptor. TX descriptor status. TX descriptor address. 20. And even that's really a base, but now that's getting really long. We can always come back to that. Plus 30 is RX buffer adder. System design. I mean, I've done some system design. I think it would sort of depend on what more specifically you meant. I do a fair bit at work in terms of the sort of CI/CD stuff that we were talking about earlier. And obviously I've designed this operating system. But if you're talking about like formal methods, it's been a few years. So it would really depend. So 36 is the command register. I guess we'll just call that command register. 38 is the current address of packet read. Not Amazon specifically, it's yes, a large company. I don't really want to get more specific than that. Interrupt mask. Interrupt mask. 3E. Down here is interrupt status. Should probably be putting the numbers in. Yes, Sulfum. The make and model of my first car, it was a Toyota Accord 2014. The last 4 digits of my social, that's 1234. Welcome in. I hope you're having a great day. Status is OX3E. I don't know if I want to sync these up. I go back and forth on this. Sometimes I'm like, I should really align all of these numbers, and sometimes I'm like, no alignment. Everything must be all the way to the left, which is certainly what the all the new programming languages would have me do. Thou shalt not align this. OX40 is the transmit configuration register. I think we're going for TX right now. We may regret that decision. 44 is the receive configuration. This is C. 52. I am attempting to update a network card driver for a custom operating system. So on the right here, hidden behind the web browser screen, that the web browser screen is going to go away in a second because I'm about to have all of these transcribed, is an old version of this network driver, and it uses a bunch of interfaces that don't exist anymore, and also is it's just super bad. So I want to make it better. This is called config1, which is not going to be confusing at all. Let's dump this window. Yeah, so over here we have, you see this is RTL 8139 IRQ handler, RTL 8139 init, RTL 8139 send packet, and you can sort of, I don't know whether, certainly I look at that and I say, this looks like some not so fun code. Thank you for the follows, guys. I don't have anything set up to watch that, but I see those came through in the activity feed. Hopefully we'll keep it cerebral. I don't know. I'll do my best. So I look at this code. I know different people have different sensibilities. I look at this code and I say, ew. I mean, there's all these, right? We just went down the path of writing down all of these names because I hate these numbers, right? Like, why is this OX20? Well, whatever a TX adder off is OX20 plus TX slot minus 1 times 4. Yeah, doesn't that make sense? Surely that just makes sense to you. And that's why I want to change it. Years of experience. So I've been programming for a long time. I have been programming, I don't know, probably like 10 years. In C, probably, well, I started this project in late 2016, early 2017, because I was going into a C class in college, and the C class was like, I called it, it was an intro programming class, because I didn't go to college for computer science. So the C class was like, this is what a data type is, and this is how you read a number from this. And I was like, this is ridiculous. I've been programming for years. We've already had 3 programming classes. I'm just going to do my own thing. And I started writing an operating system. Welcome, Egoist. Yes, Realtek. Actually, I say, I'm going to hedge this, a lot of, maybe not most, a lot of providers or hardware developers will publish their datasheets because they want people like me to do exactly this. Right, Realtek would be very happy for me to support their card in my system, because if my system becomes big, well, they'll sell more cards. Or really, they're happy for somebody to make the Linux driver for free so they don't have to. So they'll publish. This is not going to have internal data. This is not going to have how it works. But what this is going to tell me is, well, these are the publicly documented, these are the registers that I can use if I want to set the descriptor 0 transmit status to ABC. Well, this is the documented interface that I would use to do that. And I think this has pin stuff too, so you would use this data sheet section 5, if you were interested in using this interface card in your own project, like if you were making a board and you wanted to know about, oh, well, this is literally the pins. AD31 is pin number 120, and that's the PCI address and data multiplexing pin. And pin number 75 is the pin that you turn on to request starting the clock. And they publish it because they want people to use their stuff, right? They're very happy for people to buy their chips and integrate them into stuff. And if you were doing, let's say you were building network cards for sale, for like real mass production, if you were confident that you were going to sell 100,000 units or something, and you wanted to use this chip, you would probably be able, depending on the hardware relationship, to like sign an NDA and get internal details that you could use to optimize or debug, where this is just really going to be sort of the superficial, high-level, publicly documented interface. It's not going to reveal any of their proprietary information. Probably. Some vendors are very like, have everything. Some vendors will give you nothing unless you sign an NDA. I know that's been a big problem with the Raspberry Pi ecosystem, is that it's very, very difficult to get documentation out of Broadcom. So the CPU on the Raspberry Pi, you just can't get anything unless you're willing to convince them that you can sell 10,000 units or something, and good luck. But now I have to decide how much I want to... I mean, really, for this init code, I think I actually do basically want to just port this. Because I'm not particularly interested in refiguring out how this init code works. So we will think about going into more detail on the sending and receiving packet stuff, but for this, I think we basically just want to copy this function and change it out for like get rid of all of the magic numbers and stuff. But I think we're just going to start by copying this. Which makes me kind of sad, but this is where we live. So for starters, struct netif doesn't exist. Struct RTL 8139IF doesn't exist. So we have to come up with some replacements for those. We have no idea what's going to be in there. And I'm not going to make any effort to distinguish generic stuff from specific stuff. Thanks for the follows, Sanchez and D-Word. Appreciate you. Hope you're having a good day. In the past, right, so in this previous version I had, a net interface, and then inside that we have an RTL 8139 kind of network interface. And I don't want to replicate that yet because I don't know what is going to be important to separate and what is not going to be important to separate. So right now we're just going to call it struct interface. We're not going to worry about it. Any state that I need to save, I'll just save it in struct interface and we'll abstract it later. Zmalloc is a wrapper that I wrote. We'll see whether we end up using it again, but it is literally just, so in C, if you call malloc, you're not guaranteed anything inside of that. So malloc just grabs Alex from the heap and returns it. But if you call calloc, it is guaranteed, the interface is different. You get, instead of a length, you get a count and of an object count and a number of objects, a size of objects. So you got this different interface that internally you basically just multiply. And there's some subtlety there where it, like if this count times length overflows, it's supposed to do something different. I'm not caring about that right now. But the thing with calloc is you're guaranteed that the allocation will be 0. So it then mem sets that to 0. I think it's kind of weird that it's these two different interfaces that are different in two ways, right? This is a count and a length, but it also allocates to 0. This is just a length, but you get no guarantees. So zmalloc is just, I wrote a wrapper that does that. Just gives me all zeros. What do I think about gmalloc or ccmalloc? I think those are really interesting projects. I think they are really useful. I know at work we have like a special built version of Ruby just so that we could sub in gmalloc because it was so much better than the operating system, than the libcmalloc on the operating system that we were using. Yeah, I think they're super cool. I think people should investigate them. I think Rust uses it as the default, right? gmalloc. So I think it's great that people are doing work in that space. And I also hope that more like libc, the operating system vendors will take that competition in stride and come up with better built-in mallocs. I know they're kind of constrained by backwards compatibility in cases, and glibc has the particular problem of the unexec problem. I don't know if you guys have heard of this, that one of the reasons it's so hard to improve the internal data structures of glibc, right, the normal libc, is that one of the interfaces it supports is start a program, run it for a while, then take its heap, what's called unexec it, take all of the data that it's allocated, save that back out into an executable file so that you can like start an executable in the middle of running later. And it's this really bananas amount of complexity that's basically only there for Emacs. Emacs uses it because it's so slow to run all the Emacs Lisp to start Emacs, that what they do is in their build process, they build like a base version of Emacs. They run it with the compiled bytecode of all their eLisp. They wait for it to start up, and then they unexec all those data structures back out onto disk, and so it relies on the internal structure of malloc. Crazy stuff. So, what do we need? Well, we need a struct interface. And we'll call it interface. This is something I love about doing this in C, is that because I don't use type defs, I don't tag my this is not C++. This doesn't take the name interface. The name is only useful if you add the tag struct. It's a tagged namespace. And that means that I don't have to worry about naming this variable. Sure, I could call it like new RTL8139 or something, but it makes sense to me that if it's a struct interface, it should be called interface, and they don't interfere because this is a struct name and this is a variable name, and those are completely separate things, which is great. And I don't know why, well, I know why languages don't do this, but I don't like it, and they should do this. I am allergic to short names now. So we're going to stop using the short name of PCI adder. And now we know that we need a PCI address, and that is apparently a uint32t. So let's add that to the struct. This I don't know that I love. I mean, these are still magic numbers, right? This 0x04 is just like an offset into the PCI configuration space. This 0x04 is the same. This 0x04 is a different one. And we've named the command cmd. I'm not a fan of this particularly, but I think I'm gonna live with it for the moment. I'm more interested in fixing these the names from up above than I am interested in fixing that. So let's v-split so that we can keep this on the screen and keep going down and see if we can't figure or fix up some of these IO register names instead of. So this is not the 3C from over there. This is a PCI based thing. I should actually just say every instance of PCI adder close word is PCI address now, instead of trying to fix those one at a time. I don't particularly want to print that out, and we have a supposition that we'll want an IO base. I think I agree with that again. So IO base, these are, the PCI address is one way to interact with this device. This device has an address on the PCI bus that we can send configuration to, as we do up here, right? We read from this address on the PCI bus, we save that, then we write back to the same address. And IO is just a different bus that this device also exposes on. And the IO space is read and written in a different way. It's got a different address, it's a different length, but I get that address from the PCI configuration space, and it will be helpful to me to save it so that I can not need to get it again. It will also be helpful to me if I make this consistent and call it IO_base. We enable IRQs, apparently, yes, we get the IRQ number from the PCI configuration space. Again, I don't really want to print that out. Both of these I agree with still. I want to save that IRQ, and I want to unmask it. I do agree that it would be useful to get the MAC address. I don't have any of these functions anymore. Struct MACadder doesn't exist anymore. Print MACadder, none of this exists anymore. So for the moment, I think we're just going to say to do. Problem for later me, when I have this stuff a little more fleshed out. I'd really like to be able to send, if we can get this so that I can send just some like generic, doesn't have to be real network traffic, I think that would be really cool for today. I don't think we're going to get as far as that. So this is config1, which is just so helpful. And I wonder why does sending 0 to config1, apparently that powers on the interface, and I'm kind of curious to know why that is. So let's find config1, which is, what did we say, 52. Here's configuration register 1. So, well, okay, 0-bit of that is power management enable, which seems sort of logical that it might have something to do with turning on the power. A, denote the new cap bit in the PCI configuration space, offset 6 hex. B, denote the cap pointer in the PCI. Oh my goodness. Most of this is writable. Driver load. Software may use this bit to make sure the driver has been loaded. That's kind of entertaining. Very helpful sentence here. Writing 1 is 1. Writing 0 is 0. Very helpful. Well, okay. I think we're gonna... I don't think we understand why writing a 0 to config 1 is helping, but I think we're just gonna do it for the moment because I'd like to make progress and not stare at this document for the rest of my life. So 0x37 is command. 0x37 is command. And this is another example. We could figure out what this OX10 means. But we'll do that later. Not particularly interested in inheriting my old printfs. Really not interested in using uint pointer t there. That was I went through an old period where I enjoyed using these. Like this shouldn't even be. This should be a fizz adder t. And obviously that's going to involve importing headers. Where does that come from? Looks like it comes from systypes. So this is a idea here is to use semantic types instead of, because what is, I mean, uint pointer t, as far as like this physical buffer, uint pointer t just means an integer big enough to contain a pointer. That doesn't actually help me understand anything about what's going on here. And yes, it doesn't matter because it's C and it's a compatible type, so it doesn't matter. It doesn't make a difference what I put here. But I think it's nice to say it's a fizz adder t. This represents notionally a physical address. And if I was doing something like dumping the debug information, it would tell me, oh, this was a fizz adder t as opposed to some sort of virtual address. Just semantically, potentially a little bit different. 0x30 is the RX buffer address. Isn't that so much better? 3C is interrupt mask. And I don't know why I've got so many zeros there. TXOK and RXOK, that seems like a reasonable comment. I don't remember what that said. It said OX40. OX40 is TX config. 44 is RX config. 37 is config. Well, it's not. It's command. And that's everything we've got here. We're not inheriting that. We may not have interrupt IRQ handlers. That is still a thing. It's wrong though. Okay. So we see in the code that I'm editing here, IRQ handlers is defined as, this is an example of where C is very annoyingly confusing, is this type signature. Because there are elements of the type on both sides. But a hot tip for anyone who has not seen it, highly recommend a website called CDecal, which brands itself as a translator, C gibberish to English. And CDecal will tell us exactly what's going on here. If I don't go to the wrong page, I meant to go here. So void open parenthesis star IRQ handlers 16 parenthesis interrupt frame star. This should be fine just with the names. I shouldn't have to. Okay, what don't you like? I would have expected that to. Do you not like the, you don't like the type? All right, well, we're gonna make the type, this was called IRQ handlers. We're gonna make the type int because CDECL doesn't understand custom types. But if we make the type int, it tells us declare IRQ handlers as an array of 16 pointers to functions who take pointers to integers. So this is an array. IRQ handlers is an array of 16 pointers to functions that take integers, integer pointer, or really interrupt frame pointer, and return void. And that is what this is. It's an array of 16 function pointers. But that's not what IRQ handlers is today. Today, IRQ handlers is defined as an array of lists, which are a custom data type that I have, and means that this will need to be updated, right? What this is trying to do is just say, well, there are 16 IRQs. These are the handlers for all 16 of them. And whatever IRQ this one has, this is the handler for it. But that's not how the system works anymore, because it turns out you can have more than one thing on the same IRQ. So I built this system after that at some point to list out handlers and install new ones. And yeah, so instead of having an array of 16, I've got an array of 16 lists that contain interrupt handlers. And the main change I should have to do is just say IRQ install for that IRQ the function pointer. Everything should be exactly the same, except for I have to figure out what impl is supposed to be. I have to understand my own code. That's going to be the biggest challenge of the night. So IRQ handler, what is IRQ handler doing? Interrupt number. If there are no interrupt handlers for that number, return else handle R. Where's R? Frame impl. Okay. That makes sense to me. So we'll probably need to include the header for that, which should be ngirq.h. And then instead of this, we're going to say irq install irq rtl. Well, I don't know. We haven't named this function yet because we haven't written it. For now. Which will take an interrupt frame and the interface, and we will install that. RTL 8139 interrupt handler. And then the other part of this is we need a stable pointer to interface, and because we're going to need to be able to give this the interface in a way that it can pull it up later, and we have not made that yet. But really all of this is sort of built on the idea that the interface is a pointer at this point anyway. So I think we're actually just going to fulfill that expectation and add zmalloc back on here. I don't know that I want to keep that forever. Because, and that would make this a pointer. I'm really trying these days to avoid resorting to pointers like that. I was really hoping that RTL8139 init would be able to return, right? Instead of this being void, it would be able to be struct interface. But if I'm going to need, if I'm gonna need to install the IRQ, I mean, I don't have to install the IRQ at this point, but at least for now, I need that that address to be stable in order to install the IRQ. So I think we're gonna do this for the moment, and we will see where that goes from here. We do. This is definitely not going to be the case, and we're going to ignore that for the moment because it's not necessary. We have none of that. We have none of that. Okay, so that sort of finishes, except that this buffer needs to be on interface, and I agree that this buffer should be stored there, so let's put it here. Store the buffer. This is not RTL. This is interface, interface. This is not RTL, this is interface. Do we have anything left called RTL? Yes, we do. And this is totally legitimate. I made a very awkward decision when I wrote this the first time to make these transmit slots 1, 2, 3, and 4. And I did that because the documentation calls them 1, 2, 3, and 4. Like if I pull up, this is a different document. This is called the RTL8139 Programming Guide. And if we, which is like a terrible, I mean, look at this. It's just awful. No, it doesn't even call them 1 through 4. It calls them 0 through 3. One of these documents calls them 1 through 4. And I just like went with that. No, this one doesn't even do that. Somewhere I found a document that called them 1 through 4. But the only time you ever interface with the hardware, you're sending slot number -1. So it was just such a, I don't know why I stored these as 1 through 4. I really should have stored them as 0 through 3 because it makes the math so much simpler. So we're just not, we're gonna just store it as 0 this time. We're not gonna make that mistake again. I think that's a pretty reasonable decision. Anything else that should need changing? It doesn't really look like it. It would be nice to, we're not really going to do anything about that. It would be nice to define the PCI. So the way that you find PCI devices is by looking for their code. They have like a code, and this should tell us what the code is that we're looking for pretty high up on the sheet because it's very important for, no, not the hardware stuff. It's very important to be able to like do anything. PCI bus interface, no, this is all hardware stuff. I mean, one of the numbers is literally 8139, so. All right, I will just pull it from, it might be in here. in the old code, or if it's not in the old code, we can get it from the old. Where can we get it from? Actually, I can just get it from the internet. 8139 PCI. It's not address. Is this going to give me the right thing? The OSDev wiki is probably going to tell me what I need to know. No. There it is. Vendor ID OX10EC device ID 8139. That's what I needed to know. 2. Vendor ID X10EC. Find device. Oh, look at that. They're the same length. Isn't that beautiful? 8139. All right. So does this build? That's the next question. Does it build at all? This is the list of all the files. 2. No, it does not. But it does not build because I need to add more header files. So we definitely used virtual memory. Oh, that's going to be an interesting question. Is do I still have the physical allocate continuous function? That might be gone. That's definitely gone. I definitely don't have that anymore. Okay. So I guess we're going to have to write a function that allows us to allocate a range, a contiguous range of memory. That is necessary because the device, it's mentioned, nope, there's no comment or anything. It's necessary because this receive buffer, the programmer, am interacting with it through virtual memory, right? So the programmer, am interacting with it up at this RX buffer address, which is going to be way up in kernel space. It's going to be, I don't know, doesn't really matter. It's somewhere. It's virtual memory. Doesn't matter where it is. But the card is not interacting with it through virtual memory. The card, the way PCI works, the reason PCI Express is so fast is that physical hardware is writing through directly to RAM on the computer, right? It's not going through the CPU. It's not going through the operating system. It's literally writing the packet into RAM, which means when it writes the packet into RAM, the packet has to be in a contiguous buffer, where the virtual memory system, I mean, I can show this pretty easily, I think. Run -m. If I do info memory, or info TLB should actually be better. These are the mappings right now of virtual addresses in the kernel. This is coming out of my emulator. Virtual addresses in the kernel to physical addresses in RAM. And you see, yes, like many of these are incrementing. So the page 0C06C0000, that page is backed by the physical memory that lives at A63000. This is real RAM that actually exists in the system. This is just funny money numbers that were made up and mapped. So this is what the kernel sees, and this is what the hardware sees. And yeah, these are pretty continuous, right? 0000, 3000, 1000, 4, 2, 5. But that's just because the logic to allocate these things happens to go, right? I happen to allocate these from the bottom up in a line. and I happen to allocate these from the bottom up in a line. And by the time we get up here, we'll see some stuff. Well, here are two adjacent pages of virtual memory, 7,000, 8,000. And in physical memory, those are like super far apart, 31,000 to 4E000. And then the next two are lined up, 4E, 4F. And then the one after that is way back on the other side. It's even further away. It's at 21000, because these are pages that were probably used early in the boot process. They were freed, they were done, they were used up. And then something else, whatever is allocating memory at this C175, got them when it was looking for memory. So this is probably, for where it is, this is probably like the heap. And if I was to just say, oh, that card gets 16 megabytes from the malloc heap, right? Makes a lot of sense, right? Very easy. I could very easily have this sort of situation. So I tell the card, I tell the physical hardware, oh, write your packets. You've got 16 megabytes and it starts at 31000. Well, sure, I'll read the first 4 kilobytes of that. But then it's writing to 32, 33, 34, and I'm reading 4E, 4F, 21. So I have to guarantee when I create the receive buffer for this card, I have to guarantee that I get only just like these pages, contiguous, linear, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 6A, 6B. And currently, because I rewrote the physical allocation code some months ago and have never bothered to make a new function that allows me to do that. So we are going to have to try to figure it out now. It used to be, I forget why, I feel like it used to be easy. Maybe it didn't used to be easy to do that. Now I think this might be a little bit annoying, because the way contiguous, which is going to take like, I don't know, n pages. That could either be number of pages or it could be amount of memory to pull. I don't know which is going to be better. Do we have any? We do have some precedent. In PM set, we use a base address and a top address, which is kind of interesting. PM decref is just a single page. PM incref is just a single page. PM ref count is just a single page. I think we're going to start with a number of pages, and if we end up doing anything that calculates like how many bytes are in this range, I think we're going to change it. But so what we're going to need to do, these allocations, the page allocations are stored in a big array, because at least for the bottom of memory, right from the time the operating system boots up, I need to know what is used and what is not. That's very, right, it's very important. So the way that works for pmalloc here, you see, I'm just searching through that array, and when I find anything with no refs, claim it, right? Ref counts ++, mutex unlock, and return that page address. What I'll need to do for contiguous is just have 2 loops, right? We'll look for, seems logical at least, I is 0, I is less than n base, and then if the ref count is not 0, we'll go ahead and say next. go ahead and copy this as well, which is just the there is no viable option. So now we found a potential candidate, right? We found one free page. So now the question is, are all pages j less than n pages free? And so if something is not free, this is actually going to be, so we could just say continue, and that would be fine. It would work, but imagine the case where we want 100 pages, but we have 99, right? There's 99 pages free, and then there's some that are not. There's one that's not free. And we sort of have to consider how this function is going to go. So we can't fulfill this allocation, but if we try here, we're going to count up to 99, and then it's going to say, nope, continue. It's going to increment I by 1. And so it's going to try from here, and it's going to find the same thing because it can't have changed. It's going to find, oh, well, here there's 98 in a row, and here there's 97 in a row, and here there's 96 in a row. So what we'll want to do is we'll say, if we don't find it, we will want to break out of this, but we will also want to set I equal to j plus 1. So we'll just say, like, hey, that wasn't available, that slot wasn't available. It will be useless to check anything from here until after the next used page. And then if we get past this, that's going to be interesting, right? So if I have to figure out a way to check if this is actually breaking or not, because this break is going to break out of this for loop. So I have to verify whether j got all the way to the end or not. And I guess we'll do that with like rule not found. Not found is true. If not found, try again. Else, now we know we're good. Return, well, now we have to increment all of those pages. Yeah. So now for I up to increment all the ref counts up to j and return I times page size. All right, that feels like it'll work to me. Don't really have a good way to test it, so we might kind of. Actually, I do. I have a way that we can test that. Yeah, we can make a little test program. We'll figure it out. Let's go ahead and add it to the physical memory management system, the header, pmalloc contiguous, and how do we want to test it? I think we'll just make a So there's a couple of things, right? We could make a user mode program that calls a function somehow. We'd have to probably have to make a new system call or add a new parameter to an existing system call. That could be, I mean, it would be fine. It would work. It's a little more effort than I think I want to do. I think we're just going to kind of slip this in inside of the TTY system. So this is what is controlling input and output that goes to, this is not the shell. This is what controls what the shell gets. This is literally like when you get a character on the serial port, give it to the shell, put it in the buffer for the, and so a thing that I do sometimes is I'll add in, I have a couple of control characters. As you see, if I get Control C, well, this is it's not a Linux box. This is a Unix box. If you get Control C, you do something. We send a signal to the serial TTY's controlling P group. This is how SIGINT works on Linux. This is how your Control C kills programs. There's a piece of code in the kernel that's listening for the character Control C, which is just the character 3, the ASCII character 3, and will send a signal to the process when it sees it. So all we have to do is just add a new control character here quickly, and I have to pick one that's not in use. I think I like using Y. I have a sort of vague recollection that Y is reasonably good. I don't think this is going to have PMM, so we're not going to have those functions here. So I'm just going to stub it out. I'm going to say it's called PMalloc contiguous size t. So this is I'm just forward declaring, hey, this function exists, C compiler, believe me. And we'll allocate 100 pages. And we'll store that. Put T, and we'll print it out. That's a ZU. I should not use ZU for that. I should use ZX so that we get the hexadecimal version, or P. Actually, we use P. P is the formatting control character for a pointer, and that's basically what I want to print this as a pointer so that it looks like a pointer. It's not actually a pointer, but I want to print it like a pointer. That did not build. It did not build because of more problems in the RTL thing. So we're actually going to, we know that this is going to be a blocker. We're actually going to just not bother with that yet. Appears to have built the TTY stuff. And if I say Control Y, we allocated 100 pages. I don't think I believe that 100 pages were available after getting all the way through the boot up process, that 100 pages were available at D000, that close to the bottom. I don't think I believe it, and it appears to have crashed the system. So, okay, that looks a lot more reasonable. 100 pages, A4B000, and we can, oh, no, that's killed it again. That's interesting. Okay. That's really interesting. That's super killing it. Is 100 pages too much? I'm glad I'm testing this. I still said 100 pages. Have I like broken this if statement somehow? Right now this should do nothing, and it does indeed seem to do nothing. What if I just print this out? I mean, I would also believe that that means it's like trampling stuff, that I might have gotten one of the logic elements of this wrong, and it's double allocating pages or something. So the whole system is just falling apart because it's losing data that needed to exist before. I would believe that. Let's see if we can't figure out why that would be. Well, okay, so here's definitely, it's definitely not the problem, because those were not that high, but we do have a problem here, which is if let's say I is like 1 page short of the end of the number of pages, this is still going to try to look through I plus n pages. So if this is not 0, continue. If I plus n pages, the real big n pages, sorry, if I plus little n pages, all right, that's a little confusing, is greater than the total number of pages available, break, right? There is nothing we can do. Should that I guess it probably should n pages, because it's not called n pages, it's called n base, which is also a little confusing. Okay, so it's not triggering that, so we know that that's not the problem. For j, no, there's another problem. J, that needs to be j. We did all kinds of things wrong here. J, so I was searching from j equals 0 to small n pages, and then only looking at I. So this was just succeeding every single time. No matter what, it was allocating all of the pages, just everything after the first, whatever the first page that was free, it was just allocating 100 pages after that and messing up everything else. That is a known problem. Okay. Still, incidentally, crashing the system. So we haven't actually solved the problem yet. If so not found is telling us that something has gone wrong. If something between I and I plus n pages is not available, we skip I forward to j plus 1. Actually, this should really be j, because it's going to get incremented by the outer loop anyway. So we really just want that to be j. We set not found true. That just lets us break out of here, and we're done with that. So that all feels like it should be right. Gosh. And I'm not even using these pages. Like, its allocation should not... Really? I'm not even using these pages. It's not like these allocations should be breaking anything. I'm just touching the ref count. So why would that be crashing the system? We might want to interrogate this situation a little more closely. So I say Control Y. That says it's allocated 10 pages at EOOO. If I hit enter a few times, okay, now it's stopped taking my enters. I can still do some things. So for example, I can hit Control T, and Control T is V status, and V status is telling me what's running. Well, what's running is the kernel doing nothing. Which, I mean, this feels like a class of problem that I had a long time ago where a thread would like get forgotten, would get left behind, and it just wouldn't be running for reasons like it would get dropped out of the running queue is what would happen, and so it would never be scheduled again, and you would have this behavior that the system would still be running. It hasn't crashed, but it's just not accepting input anymore because the shell isn't running. I mean, is Control Y used somewhere else? It is. Oh, I have a file called WQ. That's not good. It is used elsewhere. It's actually used in here, so. Okay. We probably shouldn't use Control Y, or at least I should get rid of this Control Y. Not that it makes a difference, because that's an else if. Hello. That's new. That is new indeed. This is we blew the stack, right? I mean, you can see there's like hundreds of thread switch calls here. We blew the stack because... that one was, so that crash happened because we were holding this lock. This is a really problematic situation. It's these this just can't. I really hate doing this. So the problem here is that I took the physical memory management lock in order to make sure that nobody else, right, if this thread gets scheduled out, nobody else can call PM alloc and like, oh, let's say my thread is actually in here right now, right? I'm halfway through setting these ref counts. I've already chosen where I'm going to set. That's already done. I'm actually setting these ref counts right now, and I get scheduled out, right? I run out of time running, and somebody else gets to run. And then they call PM alloc, and they get the page immediately after the one that I'm halfway through. So now we're both claiming the same page at the same time. And that's obviously not good. So I wrap it in this lock to prevent that from happening. That if I'm in PM allocate contiguous and some other thread tries to call PM alloc, it will get stuck here until I am done. it will get stuck. It will say, I can't make any progress right now. I've got to go. But in this case, we were in a situation where, so some thread is holding the physical memory lock, and a different thread gets a page fault. So I was talking earlier about how virtual memory is funny money and how we just sort of willy-nilly map it to physical memory. And that's very true, right? Virtual memory, I can allocate it however I want to. I can put it wherever I want to. I can allocate 1,000 gigabytes, 1,000 terabytes if I want, of virtual memory. And it's fine as long as I don't try to use it. And what happens when you try to use it is you get what's called a page fault. This is a feature of the CPU. The CPU says, hey, you are trying to use memory there's no valid mapping for that memory, right? You've given out, it's like banking, right? I've given out an ETF or something, and no, that's not a good analogy, and I really shouldn't go there. I've given out addresses and I've said, hey, you can use this address. And then when they try to do it, well, now it comes time to pay the piper. I get a page fault, and that's the CPU saying, come on, you said you could use this address, pay up, give us real memory. So that goes into my virtual memory management system, do page fault, and do page fault has decided that the correct thing to do is to allocate a page. But we can't do that because somebody else is using the physical memory manager. So you can get into, in some cases that'll be fine, right? If that thread is successfully able, without allocating any more memory, if that thread is successfully able to deschedule itself, it will be fine. But in this case, it isn't. Probably because it needs to, I'm not entirely sure. I'll be interested to see. So a thing that I can do with this is I have this program dump.rb-a that'll let us see what line of code these are. So this is just reading it's just reading that output and translating, it's translating this address using the binary into a line of code. So we can see where it's actually getting stuck. 334. It's actually getting stuck. Technically, so the way these things end up working, it ends up pushing the thing that you would return to. So it's getting stuck here in thread block. Or more specifically, it's calling thread block, and thread block it ends up calling the same thing, right? Thread block calls thread sched and thread switch. Thread switch, we enter thread switch, and we call thread block, and thread block calls thread switch. That's why we're getting this loop. And the reason for that is the only thing that can run can't run, because the thing that has to run is locked behind that lock, and the thing that is it's a deadlock, right? Nothing can progress at this point. So I hate doing this, but the thing I'm going to do is just wrap these in a disable IRQs. This is going to prevent anything from scheduling across this. I will do a better job with this later. I intend to do some intelligent stuff with the mutexes that allows them to like smartly, not smartly necessarily, but that allows them to not get into this situation. I want to be able to like mark a mutex as, well, this is a critical section mutex. don't allow scheduling across this mutex and have that just sort of work. And I don't have anything there. So right now we're going to do this, and I'm going to be really upset and sad with myself, and we're going to hope that that is not our problem. So that was our crash from a second ago, but that is not the problem. This is such a bizarre problem. So the next thing that I want to do is just give myself another control character, because I have a function that will give me a lot more information about what's going on here, and I just need to call it, and I can't call it because there's nothing running. Oh, actually, I wonder, before I do that, let's try one other thing quickly. Control Y, enter, dead. I'm not used to thinking this way yet because it's new, but I recently added a way to switch to a background shell that's still working, and that will let us see that has died too. Well, I was excited. That's really interesting. And it's not like it's immediate. It's after a couple enters or you try to run something. And all of this just for having touched some stuff in the... I think we need to start eliminating possibilities here. We need to start figuring out why this is happening and narrow it down. So, step one, does it happen if we have code in control Y, but we don't use it? We don't actually use the new function, right? Just what if it's to do with that? No, I think we can safely say that this is actually being caused by the new pmalloc contiguous function. So what if we called it with 0 pages? What should it do? What would it do if I called it with 0 pages? If I call it with 0 pages, well, this may not be very useful because it's going to run. Oh no. Oh, what is this going to do? This is going to run for every page. If that ref count is 0, if I am, so this is never going to trigger. This is never going to run, right? This is just going to skip. So not found is going to be false. So if I call it with 0 pages, it will allocate 1 page. It will behave exactly like pmalloc. Okay. Interesting. We can see if my theory is correct if we run it. It still kills us. So not exactly like. I guess that would be the next question is, does pmalloc do the same thing if I do that here? Is pmalloc just broken? And I've never realized it. That's not happy because pmalloc doesn't exist here. Not to, yeah, because I wanted a script for some reason. pmalloc doesn't exist here. It does not. That's correct. But now it does. Control Y. That looks like it's doing the right thing. It's not crashing. So it's definitely something to do with the new function. So what if we already called that with 0 pages. And 0 pages also caused our issue. So I think that might be an interesting place to stay. Please do, anyone who's watching, if you have questions about what's going on, please feel free to ask. I know I'm kind of zipping around here. This is just a code base that I've spent a very long time in. So if you want me to slow down or explain something, please just let me know. PMM. So contiguous, even with, right, if I guess we could, let's make a, actually, yeah, so this should never run, and in fact, this should never run. Right, if that's 0, that should be false right from the beginning, and so should this. So really, if it's 0, it should look like this, and it should find a ref count that is not PMRef 0, and then it should return that number without even allocating it. So why would that be crashing the system? And yet it still is. And we can go to our backup shell, and the backup shell is dead. That's, well, okay. Yep, nope, okay, yeah, I've got it. Everything makes sense. I just never unlocked the mutex, which is, and so as soon as you need to actually allocate anything, everything dies. Yep, that makes a lot of sense. I even went to the effort to enable IRQs, but I just never unlocked the mutex. So whatever the next thing was that tried to allocate any memory, which was definitely the next command or after a couple of IO cycles. And that was definitely the problem. Okay, so now let's allocate 100 pages. Let's go back like 20 minutes. Let's allocate 100 pages, and let's see if our output indicates that that is actually happening. So we have a proc file. I think it's called memory. It's not called memory. We have a proc file called mem. This is why I'm now allergic to shortenings, because that's kind of nonsense. And this tells me the status of all physical memory according to the physical memory management system. So let's see if we have approximately 100 pages after AF4 AOOO. A4A, not AF4. Oof. I was like, wait a minute. And that is not what I see. What I see is A4A is currently unused. A4B to A8A is in use. So that might be like an off by 1 in one of these. It might be an off by 1 in the printing system too. Let's find out what A8A minus A4B is. A4B X A4B. A8A minus A4B is 63 pages. So that's definitely not correct. So we're allocating, we actually did pass n pages. That's all correct. Now I'm glad I'm testing this. Why would that not... I'm not like editing n pages. No. We're definitely using J here, which is the thing that's definitely getting incremented. Why would that not be incrementing 100 pages? All right, well, not background. Let's just print out J. That is a ZU. Thanks for the follow, Quake. And Flocion. Looks like I missed your follow a little earlier. Thanks, guys. Hope you're having a good day. Control Y. We allocated 100 pages. And thank you, Vaticoden. I hope you're having a good day, too. And okay, so interesting. I probably should have done this before. I can keep hitting this and I get the same address, which is, I think, a bit of a red flag. And also, it's never printing this number. So we're not getting there at all. So how could we get out of this function here, right? This is the only place that this function can return a value. Every other place it's returning, well, the only other way out is here, where it returns 0. So we're here, but we're not running this. Well, the only way for that to be the case would be for me to be really dumb. Because J is not, in fact, right, n pages is smaller than I for almost all values of I. What we don't actually care about going from I to n pages. We care about going from 0 to I plus n pages. So that's I plus j here, and then we return I. And that I would expect to print the numbers 1 through 100, which it does. I would expect it to show up in mem, which it might. ADB minus A40, that's certainly more believable. ADB minus, well, not A40, we actually care about A4A. A4A, that's 141. A4A is more than 100. Okay, so now we've done it again, and we ended up with A44. We had A4A the first time, and the second time we had A44. Which I think is not super believable. Okay, the third time we get AB6, the fourth time we get BA1. Those are more believable. But B1A, not BA6, B1A, I mean, it's in the middle of a big in-use portion, but so was, I mean, AB6 was also in the middle of this previously in use portion. So I don't think I believe that this is working. Gosh, this has really been my, this has been my kryptonite. Actually, probably for the exact same thing here. We're not actually doing any checking for the exact same reason that we just talked about. And then I does not need to equal j, it needs to increase by j. We were going, well, we were just never running this, right? Because j, again, n pages was smaller than I. So if we were looping from I to n pages, we were ending up with, it was just never checking anything after the first page. And only the first page because of this. So it was still just giving us whatever the first page was. And it was allocating 100 pages, but it was only checking the first page. AB1, B15, B79, BDD, those look much more reasonable. It's starting at a much more reasonable place. And AB1 is in this range, which is very large, it's not like giving me these previous unused, right? It's not giving me A87, it's not giving me AA4. It started at AB1, which was past AA8 at the time. So I think we might have actually sussed the bugs out of this thing. Gosh, I was so ready to just be like, it looks like it works. I don't need to test this, right? Nah, it's fine. This is so easy. So this function is now called PM with a single M, and we need to make sure that we import that. Actually, speaking of things that I need to import, I need to make sure that I commit that at this point. So let's do that. PMM include ngpmm, and we are not going to save this TTY change. I don't need that to stick around. And what else is different? We have this change in the CMake list file for that file that we're working on, and nothing else actually matters. So let's go ahead and commit this. This is pmm add contiguous us. I hate this word. Allocation function. I think that's pretty self-explanatory. Let's go ahead and send that to GitHub. And I am going to step away for just 1 second, and I will be back in like 2 minutes. Okay. So we've got that physical management change pushed. Just gonna quickly, yep, GitHub gave that a green check, so it builds fine there. So I am going to, for anyone who's new, about 100 years ago, I started working on porting this network driver forward from a very old version of my system. A lot of the interfaces have changed, so I'm basically rewriting it at this point, and my programming style has changed a lot too. So we just spent like, I don't know, probably an hour to add this function back. This is a function that I used to have in the old version of the physical memory manager. And when I rewrote the physical memory manager, I also didn't have this code in the kernel, so it left. And well, now I've rewritten it. So I'm going to put this back in the build. Right now we're just trying to get this function basically to compile. I don't need it to do anything because I don't have this all set up to test or anything like that. So we're just going to go to the CMake lists and put this in and just see what we get as far as compilation goes, which is all kinds of situations. So what are we missing? First one there was zmalloc. Where is that actually headered? It's in stdlib. I guess I just didn't even include stdlib because we're still very early as far as that is concerned. Yeah, didn't even put in the memory management. Next is the PCI config stuff, which should, I believe, be just as simple as ngPCI. Maybe not. Maybe yes. PIC IRQ unmask is x86 pic.h, which is really annoying that it's a architecture specific header, but it is what it is. PM allocate contiguous. Didn't I put that in the header? PM alloc contiguous. Okay, it's just changed name. Allergic to abbreviations. There is no TX slot in struct interface. That is not the correct this needs to be a void pointer. To smuggle it through, and it looks like that builds now. Okay. So that wasn't too problematic. I don't really want to commit that though. I don't really want to commit that. I don't know how happy I am with this yet. We may need to make a branch for this work. Because this is all very out there. I don't know. Maybe it's time for a bit of a change of gear though, because I think we've been going on this one thing really since the beginning of stream. And sure, we had that nice diversion off into the physical memory management, but we really got started with the network stuff right at the beginning. I think it's time. Maybe it'd be really interesting to see. We've been getting that bug again. I wonder if I can reproduce it. We've been getting that crash on boot a couple of times today, and I'm really upset about it. I really don't like it when the thing crashes on boot. And I just fixed a huge bug yesterday, so I'd love to fix another one today. And of course now I can't get it to happen. So that's not fun. I wish I knew what caused it. It's some stupid, it's like an alignment problem, right? There's a, if I, how does this work? If I crash the system just to sort of demonstrate so that I have one of these to highlight. These are all the registers, right? So what I see when I get this crash that I can't reproduce right now is one of these registers is just moved over by 1 byte. So it's like these bytes are in the register, and then these 2 on the end are like gone. And that means, right, wow, that's an invalid address. And so it crashes the whole computer because it's during the boot process or something. Like it's early enough or late enough that it causes knock-on effects and crashes the whole computer. But so I don't really know what to, like, it's probably in a stack, like not an alignment problem, but it's probably a problem where the stack is being modified at the wrong time by the wrong thing. And of course I can't get it to happen right now, so I don't really know. I know at some point I want to work on automated testing. I mean, I've worked on it in the past. I think I still have a program called AutoTest. No? Test? That's kind of hilarious that the test program fails right now. And it's asserting inside an assert. That's double hilarious. We might have to see if that's reproducible. No, it's not. I want to have automated testing because I want to be able to collect and test those, or come up with those kinds of want to be able to collect those kinds of stack traces, right? I'd love to be able to say, hey, run the system 500 times, and if you get like a weird crash on boot, save that dump for me to be able to analyze it later. And but I don't have that set up right now. It's on my list, and the test program is one of the things that I want to be part of that, right? I want to like boot it up and run tests and count how many times it prints the word passed. I think that's a simple, keep it simple, stupid way to do some stress on the machine. And these are, I don't know, I mean, it's testing things like print formatting, and it's testing string equality, and it's testing get PID is like doing something reasonable. It's doing something and then testing that error is 0. The output here is not particularly good just because this is not a language where I can do introspective, like I can't write unit tests. Well, I could write unit tests in a really sort of high level way if I had some huge library that would do that, but by default, just as C, I'm not going to get crazy unit testing built in, so I've just built this like thank you test, which takes a string and an assertion, and if the assertion fails, it prints failed. Test equal for 2 integers, and test string equal for 2 strings. And then some helper utilities, and then I've written some tests. Oh, that's all automated too. I didn't realize that I'd automated this printf test. That's pretty, that's pretty fun. See, like, you've got that HELL equals HELL output, but what you don't see is that HELL is test that's equal to stir and dupe hello 4. So it'd be nice if I could print that out as is, and maybe if I did some more macro nonsense I could, but it's fine for now. Yeah, and there's some like make pipe, subprocess fork, test, subprocesses, whatever. I really would love to be able to reproduce that bug though. I mean, I guess it's good, right? You know, this is certainly a lot better than it has been in the past. If I can start the system, what did we do? Probably 10 or 15 times and it not crash. That's not bad. That's, I've had worse in the past. I don't know. What's maybe we should make progress on one of these things. I've been trying to get rid of all of these lists. See, I've had success in 1 of 5, so we could try to tackle one of those, but I think that's kind of a bigger project than I want to start at late o'clock. Well, it's something that I can make like a meaningful contribution in 20 minutes. We could. The shell is behaving incorrectly as far as this read should not be from the file descriptor. I would really prefer if this read was from my buffered IO. So we could try. I'm pretty sure it's going to be really just as simple as telling standard input that it is not buffered. This is the parameter ordering. IO NBF, no buffering, and then changing this out for fread, which would be what? CB, I think it's CB1, CBlen, standard in. Let's check that. fread is, nope, it's pointer, size, number, string. So that's not what I asked for. Pointer, size, number, string. Okay, that's literally exactly what I did, and then I read it and I thought I had done it wrong. And maybe that's just enough. We'll have to make sure there's nothing else going on in SH. Seems to work though. I'd say that works. Let's just make sure there are no other references to yeah. That shouldn't be. This is not this is I don't want it to do it this way. What I want it to do we've got some ideas about so what I'd really like this to do, instead of dealing with standard in file number, is because this is the code in the shell that is trying to this is the code in the shell that is assembling the standard inputs and standard outputs of everything in a pipeline. Right, so the way a pipeline works is if I say like echo hello world, pipe it to rot 13, pipe that to rot 13 again. This is going to run 3 programs, and this program is going to have its standard output set to a pipe, which is a kernel data structure. The standard output of this program is going to be this pipe. The output of that pipe will be set to the standard input of this program, whose standard output will be set to a different pipe, another kernel data structure. And then this program, its standard input will be, again. So in this case, well, what does rot13 do when you apply it twice? Well, so we've echoed hello world, we've rot13'd it, and we've rot13'd it again, and we get hello world. And if we did it one time, it would be different because this string is sent to a different program. That program, if I just run that program without anything else, it's sitting here waiting on standard input. There's no pipe on standard input, I'm just running it. So if I type on standard input, we get exactly the same behavior. So the question really is, how do I want to handle, I guess these really do have to be dupe. I cannot try to do anything fancy here with the in userland file buffering. Because you can do dupe is a system call that will duplicate a file descriptor, right? You turn one file descriptor into 2 file descriptors, which in the default they just point to the same file, and that's not quite so helpful. But dupe 2, you give it a new descriptor and an old descriptor, and I don't know which. I guess it's this way, right? So what dupe 2 here is saying is take the next stood in FD, which is decided by this pipe up here, probably, and set that to 0, right? Set that to the standard input. And we're going to have to do it that way across the exec boundary. So all of this should be, just because any of the in user space data structures are going to be lost. So all of this really does have to be the Unix specific, not C standard, the Unix specific open and dupe and file descriptors. So I agree with this, but I don't think I agree that these should be standard in file number. In practice, the thing I'm going to switch it to is always going to return the same number, but I think at this point I'm pursuing sort of an ephemeral notion of standards compliance that doesn't matter in the real world, but really for the non-Unix specific portion of this, and I know this is like a, what's the word? It's like a platonic ideal that doesn't even make any sense, because this is tty_ctl, which is a function that I invented, and these buffering commands are commands that I invented, right? These aren't standard in any way, not even on Linux. But I think I want this to say, instead of standard in file no standard in. I think I do want to say that. So let's consider, right, why, in what case would input file not be stood in? Input file would not be stood in if we were reading a different input file, but where is that? Well, this is handle line. So where is input file set, and how does this Yeah, input file equals, well, fopen. So really what I probably should be doing, I guess the question is, why do we need this if input file is equal to standard input? So what we're doing is we're like storing this value, this file pointer called at global scope called input file, and we're assigning it to standard input and then changing it to something else if we need to. Well, I wrote this function earlier today in the previous stream that I did earlier today. I wrote a function, or I fixed a function called freopen. And one of the things I learned earlier today is that freopen, that the prime use of freopen is to change the file associated with a standard text string. So a thing that I can do is I can say, and in fact, I would need to change this to file no standard in. But the thing that I can say is instead of input file, we'll need to think about that. But instead of input file equals stood in, if we have an argv, we can just freopen stood in with this argument file. And I think that returns here fopen open failure. So that's now reassigning standard input to this file. Wow. And then so this was just broken before because I was checking if is a TTY file number standard input, which doesn't make any sense if standard input is not the input file. Sure. So these all seem entirely reasonable. It's changing the buffer mode, it's changing the interactivity. If the standard input is not a TTY, it's not interactive. But then the real question is, why does handle one line count? And I think handle one line counts I mean, what it cares about is it a TTY? And I think I'm using in what world is, I guess this is here for the world where we are doing not interactive, but still using a TTY. So I think we're going to make a few quick changes here. One, no, we're not going to care about that. We're going to trust in the compiler, that the compiler is going to optimize 6 calls to file no stood in. But I think we're going to have one more which is just, hey, is of stood in. So this is just, we're going to have a global flag that just tells me not is TTY. Is standard input a TTY or not? Because if do buffer and interactive, basically we don't want to do any of these TTY controls if it's not a TTY, right? I mean, that makes sense. You can't control a TTY that doesn't exist. So this at least duplicates the existing behavior, but I almost feel like we should do the same thing here. I know the previous was a proxy for that, but what do you not like about that? You do not like that input file is part of read line simple, and it doesn't have to be. Read line simple does not take a file. Read line simple always reads from the file name standard in. It's just that standard in might not literally be standard in. That is broken the user sh readline contract, and we can fix that. Okay, that's not great. Is that reproducible? No. So that was a spurious. Okay, don't you love that? When you make a change and the exact thing that could have gone wrong goes wrong, but it's actually just spurious. Like, what I wanted to test, right, I had a few things that I wanted to test out of that. I don't know that I have any. Yeah, I need a shell script, and we can make one quickly. That's wrong. There's no going back. And I think we're literally just going to do the same thing. Okay. I don't think that works. It does not. Interesting. Concerning. Okay, so shell script does at least nominally work. Right, just caring about, does it, like, is it able to read text still? Is readline simple working? Is you know, parsing the file working at all? It's returning 127, which it probably shouldn't be doing, but it is at least a little bit working. We could do a little minor investigation to see why that is. Unfortunately, there's just a lot going on. Because it turns out there's a lot of things that get called in a full pipeline setup and teardown. Well, okay. So let's quit this and then look at last output and see if we can find a 127 in there. That's a 127. That's very early though. I don't think I believe that. I mean, that's before any of the other processes have come into existence. So that's got to be something else. Maybe the read call. Or no. Or it wrote to standard error, arrow 127, before even starting the pipeline setup. So unfortunately, this is very similar. RG arrow in user sh. Oh, that's really unfortunate. User sh, this fprint is annoyingly ambiguous. 127. All right, so let's change this. Yeah, it's like this is quitting. Or never. It's like this is quitting. That doesn't make any sense. Just make that a plus just for now, just to be able to tell. Weird. Okay, now I can't type. Maybe that wasn't the best idea. Short number of minutes, maybe, but definitely caused some problems. I think we'll put that back on the burner. Well, I didn't find something to make some small improvements on, but I did find some bugs, so I guess that'll go on the to-do list, right? To do sh file no versus standard in, I guess. See if I can't fix that when I'm thinking a little bit more clearly. For right now, it's getting late. I'm running out of brain juice, so I think I'm gonna head to bed here. But I hope everybody has enjoyed. I hope you have a good rest of your day. And I look forward to seeing you next time. Bye-bye.